Hi, in this video sequence I'm going to demonstrate how to create an inner join, and rather than using the standard inner join operator in SQL, I'm going to demonstrate the effect using 3 relational algebra operations in sequence. So the first thing I'll do is execute a product which will give me an n times n result set. So to understand what I'm talking about, if I have 2 tables, and in table number 1 there are 3 rows, and in table number 2 there are 2 rows, then an n times n product would give me a total of 6 rows in the outset. And basically the way it works is every possible combination of rows are concatenated together, and I'll demonstrate that. Before I do, though, I'm going to go ahead and create a database in Microsoft Access, something that contains 2 tables, something that is very, very simple in order to demonstrate with. So previously, when we looked at how to create tables and relationships in Microsoft Access, I already had the database started. This time I'm going to actually start the database from scratch, so you will be seeing, that aspect of it that hasn't been demonstrated before. And I'm going to launch Microsoft Access from my quick launch toolbar, and when I get the initial screen, I'm going to choose blank database with a double click, and when I do, it opens up a table, and by default it opens it in excuse me, I'm just getting over a cold. It opens it up in sheet view, which is not what I want. In fact, I'm going to enlarge this window, and then rather than working in sheet view initially, I need to go over to the view button and choose design view. And at this point it wants to ask for a name for the table, and again I'm going to create something very simple, so I'm going to call this my pet table and tell it OK, and I'm going to create a first field. So Access, as you recall, this should seem familiar to you, automatically when I create a table tries to create a primary key, which is a good thing. It wants to name it generically ID. I'm going to modify that by calling it pet underscore ID. It wants to make this a surrogate field and give it a auto number, numeric integer data type, and that's fine. And then what I'm going to do is just add one more field to this. Now I realize this is going to be very incomplete. If this were an actual database, I would be doing a more thorough analysis of the data storage requirements, and very, very likely if I had a table where I was storing data about pets, then I would include much more about the pet than just its name. But to keep things simple, just to demonstrate the basic relational algebra operations that make up a join, I'm going to keep this extremely scaled down, and I'm going to name the next field here pet underscore name, and I'm going to make this text data type, and I'm not even going to bother to change any of this. I'll just leave it at its default length, and normally I would want to probably require this field and make some other changes here, but for my purposes and just being able to demonstrate how a join works, then I'm going to consider this to be complete and save and exit out of the table. And then I'm going to create another table, and to do that I'm going to go to the create page, choose table design, and it'll take me right into design view, and I'll add a key, primary key field, and I'll call this owner underscore ID. This looks very familiar in concept to the tables that I had in the the groomer database that I demonstrated. I'll make this a auto number field, and I'll designate this as a primary key, and then I'll also have an owner name field. Okay, so again, this is very minimal table just to demonstrate a point. So I'm going to consider this to be complete and save it, and I will save this as the owner table and say OK to that, close things up. Now if I look in the object bar, I have two tables, and I'm going to form a relationship. Now I just messed up. Before I go into the relationship diagram, I'm going to have to make a change. It's early in the morning, I'm not awake. So let's consider logically what we'd have. An owner could have many pets, but a pet would, in this scenario, only be owned by one owner. So owner is going to be on the one side of the relationship, and pet is going to be on the many side of the relationship. Pet, being the child table, really needs to have a foreign key associated with it. So I'm going to double click on the pet table, going back to the which one will that be on? The home page, and switch over to design view, and I really need to insert another column in here, that being a foreign key column. So I'll click on the current second column in the table, and then right click on the square on the left margin and choose insert row, and insert my foreign key, which I will give the same name as my parent table's primary key. So I'll name this owner ID. And since I'm going to be matching data in with data in the parent table's primary key, I have to make sure that the data types are compatible. So I'm going to choose number data type so that it is long integer and therefore compatible with the data type of the parent table's primary key. Having made that structural change to the database, I'm going to save and then exit out of the table. And at this point, I should have all the mechanisms in place in order to now create a relationship between the two tables. And so to do that, I'm going to go to the database tools page, choose relationships. It brings up a dialog box and says, what tables do you want to put in there? I'm going to highlight both of these. I will shift click and say add, and then close up the dialog box. And at this point, I have both of my tables showing up here. And if I draw a connecting line from the parent table's primary key to the child table's foreign key, I instruct the database management system to create a one-to-many relationship with the owner ID of the owner table being on the one side of the relationship, and the pet owner ID being on the many side of the relationship. In other words, parent table primary key, child table foreign key. That's exactly what I want. And without any further discussion of referential integrity, I will turn on referential integrity, and I will ignore the cascade rules, which, if it were a real database, might be useful, but for my purposes, I'm going to ignore it. And at that point, I'm going to click the Create button, and it draws the relationship the way I want it. All right, so at this point, we see that we have the proper relationship, one-to-many relationship between owner and pet. I'm going to close up the relationship diagram, and I will save. And then it's time to populate the table. So we're going to use a minimal amount of data in this so that you'll be able to see the effects of how an inner join works. And so I'm going to go to the owner table, and I will expand this column so we can see it more clearly. Now I think maybe on a lot of these applications, if you double click on that dividing line, it will automatically expand it to the right size, but apparently Access doesn't work that way. Alright, so I'm going to put in the owner's name, and I will have Chuck, And let me try to spell that with a different set of characters. Okay, so I have Chuck, hit the enter key, generates the auto number, tab over, and I will call this next one Nick. How's that? Okay, I'm only putting 2 owners in here, and I'm going to save. Now, obviously, you know, this is a pretty downsized database when I have tables with as few columns as these have, and you know, when I'm working with this small amount of data, but just bear with me if this will make sense here in a moment. I'm going to close this up. I'm going to go to the pet table, and I'm going to put in owner ID 1, which corresponds with Chuck, and I'm going to put in a pet name Bentley, and hit the tab key, and I'm going to put in a owner ID of 2, and put in a pet name of Lucy, and hit the tab key, and I'll put in owner ID 1 again, and I'll put in a another pet name Josie here. Okay, so as it turns out, I have 2 rows in the owner table, I have 3 rows in the pet table, and of the rows that are in the owner table and the pet table, row 1 will correlate logically with 2 rows in the pet table, and from the owner table, row 2 will correlate with 1 row logically in the pet table. Okay. Now, I'm going to be creating an inner join, and eventually I'm going to anticipate that there will be 3 rows in my final result set when I do an inner join. But an inner join is accomplished by performing 3 relational algebra operations in sequence, and the first operation that's performed is a product which will give me an n times n I'm so sorry to be coughing, an n times n number of rows in my result set. So let's take a look at what a product looks like first. So if I close this up and go to SQL view, so let's see, I need to create, I've been working back and forth between Microsoft Access and SQL Server so much that I'm confused by both of them right now. Okay, so if I go to create and in query design, why not use QBE grid, save me having to write. Nah, I don't think I can do that. So I'll use the QBE grid maybe later. But for now, I'm just going to close this without including any tables and switch right over to SQL view. And to create a product, I am going to go ahead and project all columns. So just do a select star, and then to create I intended to put that in uppercase, so not that it really matters, but select star, and on the next line from, now it's in the from clause that I'm going to not only communicate what tables to use, but I'm going to also communicate the product operation. And the way that's done is I'll specify one of the tables. We'll start with owner, separate it with a comma being the product operator, and then list the second. And if I put select star from owner comma pet, it will generate, in this case, 6 rows, and some of the rows will contain meaningful data and some of them will contain data that's really junk. So if I run the query, there I have it, 1, 2, 3, 4, 5, 6, and so this result set contains rows that make sense and other rows that don't make sense. And so I have the initial stage of an inner join. I have all the rows, you know, that are needed. It's just that there's some additional rows that are not needed or not wanted. So an inner join is formed by three relational algebra operations. Number one is a product. You're seeing it now. Then I'm going to have you imagine this for a moment. If I were to somehow eliminate the rows that don't make sense, okay, so 1 Chuck Bentley does make sense, 2 Nick Bentley does not make sense, 1 Chuck Lucy does not make sense, 2 Nick Lucy does make sense, 1 Chuck Josie does make sense, and 2 Nick Josie does not make sense. Okay, now here's the key to making this work. In order to eliminate the rows that I don't want, in order to clean this up, what I need to do is make sure that the primary key from the parent table is equal to the foreign key of the child table. So in the case where we have Chuck Josie, primary key on the left that's highlighted matches the key that I'm pointing at with the mouse, the foreign key, so that's a good row. Second row, the primary key associated with Nick does not match, so that one should be eliminated. Third row, primary key associated with Chuck does not match the foreign key associated with Lucy. And I hope you see what I'm talking about at this point. I'm not going to go through every single row of this, but what I'm going to do to clean this up is to go back to SQL view. Hopefully it hasn't changed anything on me. It has not. And if I then select just the rows that I want, I should be able to get close to the result that I want. So again, what's a inner join? It's a sequence of three relational operations: a product, which we saw, followed by selection, which eliminates rows, and selection is performed with a where clause. And in this case, what I want to say is where owner dot owner underscore ID equal pet dot owner underscore ID, where the primary key in one table matches the foreign key in another table. If I run this query, then I have Chuck paired with Bentley, Chuck paired with Josie, and Nick paired with Lucy. And that's exactly the rows that I want. So I was able to go from a product to the second result set and eliminate all the junk rows in the product by executing the relational algebra selection operation. And now what's left is to clean this up just a little bit more and control which columns are output. In other words, going back to SQL view, excuse me, I'm going to change the projection criteria, and I will project then owner underscore name, comma, pet underscore name, and this should give me exactly the data I want in the result set. And I messed up here somewhere. Let me see. Close that up, see what I did wrong. I left a space out here. See what that does. And there we have it. I have the two columns that I was looking for, which pairs the owner with the pet. And that is the way a inner join is created. And it's done so again by executing three relational algebra operations in sequence. First, we form a product of two tables, then we eliminate rows, and finally we eliminate columns with a projection. So it's a product followed by selection followed by projection.